All right, a few things as we start up again. First, Tom has done his video and audio for the leavemeathome.com. That's the good news. The bad news is he did it all on his phone, and we're having a hard time getting it from his phone to my Dropbox account. So my phone was ringing while I was lecturing here, and it was him. So I'm going to have to try to work with him on that, and hopefully we can get that done today. Second, I sent you some stuff today, and one of the things I sent you, so you have this, is this URL right here. All right? And what I have found, you may or may not agree, but if you go to that URL that I sent you, it's going to bring you here, which is one of the uglier websites I've ever seen. That said, it's from somebody, it's archived, all right, and it was from a place that's called hunlock.com. It is by far the best JavaScript tutorial I have ever seen, all right? And when you look at it, I'm not going to go and run through each one of these, but if you look on here, you will notice that there's a regular JavaScript tutorial, then there's another one on just numbers, another one on just strings, another one on just arrays, one on functions, one on JSON, one on dates, and one on AJAX, which is asynchronous JavaScript and XML. Noobs is just for newbies. All right, you don't have to go there, you don't have to do anything. I sent you the URL, so you all should have it. All right, but I think it's one of the better JavaScript tutorials, if not the best one I've ever seen. It's right up there. It's in the list. All right, the team picture, whatever you want to say. That's the first thing. Second thing, I got an email last night from Abby saying, hey, if we had any homework in the JavaScript stuff, yeah, but I probably didn't do a good enough job of telling you that. So I resent everything to you this morning. What we have, and this is all sent to you in 3 different emails this morning. There are some short exercises that Muroc gives, and you're going to end up doing all, you don't have to do the one for chapter 1, but you're going to end up doing all the ones for the first 12 chapters. Many of these exercises will literally take you 5 minutes to do. The longest one should take you about a half an hour. All right, plus you've got the starter files for those. These, all right, will be the labs, and then these will be the homeworks. Again, you've got the starter files for those too. They're more extensive. All right, so you're going to go through the ones through chapter 12 in here. So I sent you those this morning along with the starter files as 3 different emails. So the first email just says part 1 of 3, and it's both the PDFs. The second email is the starter files for the extra exercises. The third one is the starter files for the short exercises. Collectively, they were over 7 meg, which is why I broke it up, just so there wouldn't be any problems sending it. So the homework for chapters 2 and 3, now it's been said, it's taped, is due a week from today. So both those short exercises and the extra exercises are due 1 week from today, November 7th, by the end of class. We are now going to go over chapter 5 and then chapter 4. Those exercises will be due a week from Friday. All right? So, with that said, let me jump into the book here. And what I did, just so you know, I went back in the BMI program that I just did, I went back and put about a dozen errors in it on purpose. So we can go through debugging it as a class so you can see the kind of errors you are likely to make. Why? Because Chapter 5 is on testing and debugging. It's not a long chapter, as you can see right here. 18 pages, 19 pages, whatever. The first thing says, an introduction to testing and debugging. And it says the 3 types of errors that can occur. There are 3 types of errors. You're going to see them in just a minute, but just so you know. Syntax, runtime, and logic. This one is the hardest one to find. Once you start coding, you start to believe you're infallible. I've had people say this to me. I found their errors. Gee, somebody else must have done that. Yeah, I agree with you. Somebody else walked over to your terminal, walked in and put bad code in there and then left. I do it all. How many times did I just do it showing you that assignment or that test? All right. So those are the hardest ones to find. An example, I mean to say something like this. All right. X equals y plus z. I accidentally say x equals y minus z. That's an error in logic. So if I came up here and I had var x equal 13, var y equals 7, and var z. All right. Well, I guess I screwed that up. We'll make these nothing, 13 and 7. There we go. All right. So what I should get then for x is y plus, what I'm going to get is y plus z, 13 plus 7, 20. All right. Maybe that's what I wanted, but I put in this. So I get 13 minus 7, which is 6. Sometimes those errors are really easy to spot. Sometimes they're not. All right. Again, if you're running your program and you get funky looking results and you're like, I don't know why this is wrong, ask the person next to you or raise your hand or bring it up here or whatever. All right. The next one, I know I'm doing these out of order, is syntax. You all know that you've got an alert statement. So if I do an alert that says hello, that puts up an alert box that says hello. But if I do this, I get a syntax error because the system looks and it says, is there a built-in method called alert? And it doesn't find one. So it looks and it says, okay, did you, in your program, did you define a method or a function called alert? It doesn't find it. So it gives you an error. So syntax errors are errors in the rules of the language. All right? Then you've got runtime. And I will tell you, in many programming languages, if I do this, if I come through here and I say this, var x equal 10, var y equals 0, var z equals x divided by y. In JavaScript, you get infinity. In many other languages, the program will break. All right? And you'll get what's called a divide by 0 exception. And an exception in programming is not a good thing. So how can you get a runtime error? Well, we haven't really talked much about arrays, but if I create an array and I try to access something in the array where it makes no sense to JavaScript, it's going to throw an exception. So when you have runtime errors, they're exceptions, but you don't know that they're errors until the program runs. I'll show you another one that you could get. This is one, I get this a lot. So I come through here and I create 3 variables. Var x equal 10. Var y equals 7. Var z. I'm asking you this question. Right now, what's the value of z? It has a value. It's not 0. It's null. But if I come through there and I do an alert, and I say x equals plus x, and then y equals with y, but if I stupidly come in there and say z equals like that, I'm going to get a runtime error because it's trying to print out null. The system doesn't know how to print out null, so you're going to get an error. That would be an example of a runtime error. So those are the 3 types of errors that you can get. Syntax, which is an error in the rules of the language. The good news is the JavaScript interpreter finds those. You're going to see them as I go through this program in just a minute. Runtime, which you don't find until you're running the program. All right, and logic errors. All right. So we'll look at how to bug with Chrome's developers tools and other ways that you can also debug. So I just told you these. I'm not going to run through these again. If you don't like my description, just take a look. Take a look here on page 143. All right. So, common types of errors. These are errors, basically, they're saying common because we all make them. Misspelling words. I still do this all the time. When we get to Chapter 6, you're going to start doing get element by ID a lot. That's wrong, what's there in blue. The D on the end should be lowercased. If you make it uppercased, you'll get an error. All right? That's a syntax error. Not putting in parentheses. All right? The biggest one with that I have, I didn't even show it on here. I don't know why, but I've always done this. When you come through here and you do a prompt like this with a parse int, I leave one of those parens off. I can't tell you how many times I've done that, but it's been many, 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 many times. Problems with data in comparison, using one equal sign when you mean to use two. All right. Problems with floating point arithmetic. We've already talked about this. I'm not going to hit on it again. All right. They talk about this is the first time the author has mentioned toFixed. I've already mentioned it to you, so I don't think we really have to go over that anymore. Again, when the JavaScript engine in a browser comes to a JavaScript statement that it cannot execute, it throws an exception. So an exception is an error condition. It's not like, I've given this example before, I don't think to you guys, but maybe I have, walking down the street and I'm, walking down with my granddaughter who's about 1.5 years. Somebody says, oh, what an exceptional child. That's usually meant in a complimentary way. But in programming, when you have an exception, it's an exception to the rule. It's an exception to the norm. It's not a good thing. All right? All right. Now, they talk in here on how to plan test runs. Okay? The big thing is when you start testing a program. Okay, and maybe you saw a little bit of it when I was going through those examples. I was just trying to get through both those in an hour. All right? That was the biggest thing, biggest challenge to me, to be honest with you. But when you're going through test runs, all right, think about it with a BMI program. The height, I should have checked for blank, non-numeric, out of range on the low end, and out of range on the high end. Does that make sense? Those were my error conditions. Then I wanted to check a bunch of them that were right on the edge. So in other words, if I said that the height must be between 12 and 96, I want to check 11. I want to check 12. I want to check 96. I want to check 97. All right, I want to go through and do all those. But the idea is when you are testing your program, believe it or not, the goal of your testing is to break it. And that seems counterintuitive to most people. But much better for you to break it than if you're doing it for somebody that, or you're having a website and maybe it's got some JavaScript in it. You don't want to give that to somebody, go, yeah, make it live. They make it live and all of a sudden it breaks. You don't want that. So if you break it, it's a good thing because you found the error, you can fix the error. So when they talk about, coming up with a test plan, critical phases, that's what I just mentioned to you. All right? It is not possible, as far as I know, that you can't ever test every single possibility there is. Right? If you ask the user for input, every time you ask the user for input, you never know what they're going to put in. Maybe they're going to hit the number 5, but before they do, they're going to hold down on the control key and then hit the number 5. Why? They didn't mean to. They just did, type of thing. Again, it's fairly easy to find syntax errors and runtime errors because the program blows up. Logic errors are the hardest because if you're not looking for them, okay, you can get a lot of them. All right. So what they're starting to talk about in here is doing data validation. We've already talked about data validation. I've already shown you data validation. But there's two ways that you can code. All right. The first is, I call it the ostrich method, how the ostrich sticks its head in the sand, basically to hide or whatever. And that is, the equivalent here is to not put any error checking in and assume that the person running your program knows what they're doing. It's never a good assumption. All right. The second way is to actually validate. That means you're going to write more code. All right. And you're going to see that in just a couple minutes as we go through not only this, first we're going to go through some errors, and once we fix those up, I've got a handout for you that I'm going to give you. All right. Now it says when you use top-down coding and testing, you start by coding and testing a small portion of code. That's what I tried to show you when I was going over me doing the test. I didn't write everything and then test it. All right. I wrote the height, then tested it, then the weight, then tested it, etc. Now, Chrome's developer tools, they're a great start. All right. And I already talked about this with you that, if you've got an HTML file up, let me grab one just to show you. I mean, here's that website. I can hit F12. I can bring it up at any time. This thing is dockable. I don't want to move it because it's kind of a pain in the butt, but you can click on it and you can move it around if you want to. You can put it on the left, right, top, bottom, whatever you want. And when you look in here, you're like, well, wait a minute, there's errors in here. Yes, there are. It's not my site. But you can go into almost every website there is, hit F12, and I can guarantee you, in virtually every website that's out there, you'll find errors. All right. If you don't find errors, you'll find some kind of a warning. Something that probably, technically, should be fixed. All right, and after you hit F12, typically what I do is I go to the console. All right, now just to show you this, again, I brought this, the program that we had up before, but I put a bunch of errors in it on purpose. Usually when that happens, there's an error. So I hit F12. All right, and it says main is not identified. Almost always the problem's not in main. Almost always it's going to be in your JavaScript file. So it says in line 9. You may or may not know this. I know now that, but if I click here, it brings up the program and it shows me what that line is. All right. Now why it gave me 9, I'm not sure. But as we start looking through this, you'll start to see what some of the errors are. And again, I put these in on purpose. Notice here I spelled const wrong. I put an extra T in there on purpose. What you should notice is it's the only one that's not blue. Sometimes that's the easiest way to discover an error. All right, same thing with var down here. I left off the A. Well, that was a pretty easy fix. Some of those fixes like that are going to be easy. Some of them are not. Again, if I take out one of these parens, it's telling me that it's on line 104. It's telling me there's a missing parenthesis on line 104. So if I go here and I go down to line 104, lo and behold, that's where that one is. I just removed it. So the console is your friend when you're running through this stuff. All right? So as you guess, I would just keep working my way down here. So I'd put that parenthesis back in there. All right? Go back to here, click the reload button, press this again. Still has an error. All right. Again, there's another missing paren on line 122. Well, that was the other one that I put in there. That's down here someplace. I guess it's here. All right. Now, if you look right here, Notice this line. What's wrong with that line right there that is in gray? Somebody should be able to figure that out. There's no parenthesis on the end. All right? So I've got 1, 2 left parentheses, but only 1 right parenthesis. Here is where an editor like Notepad++ or another one, notice if I go and highlight here, there's nothing else highlighted. But if I highlight here, it highlights them both. All right, so I'm going to save. I'm going to come back. Unexpected token. It says here on line 125. Well, there it is. It found this. That's the unexpected token. The semicolon. Why? Because it was expecting, before it found that, a parenthesis. Now down to 148. Well, notice I did this again on purpose. There is no plus minus. It should have been plus plus. Now, if I, instead of plus plus, notice down here I put in minus minus, that's a logic error. The system won't find that. Now, I want to show you something that should scare you as a programmer. See this? It didn't flag that as an error. What that does say is, can I take 18.5 and assign it to BMI? And that's what it's saying. If, can I do that assignment? Yes, always. That's always going to be true. So this should be a double equals. That's, again, one of the most common programming errors that people make. All right, unexpected end of input on 184. What does that mean? Well, notice I got all the way down to the end here. And I know that the last place I had an error was up here. So I know the error's got to be in here someplace. That looks okay. That all looks okay. All right. But in here, well, what's the error? What don't I have right there? All right, my missing curly brace. Now, I think, I'm not sure, but I think everything's been fixed. Nope. Cleep. I wrote cleep going instead of keep going. All right, and that's on line 100. All right. Now, does it work? I don't know. 72. Oh, is NAN. Runtime error. What's wrong with that? The A is capitalized, and it shouldn't be on line 105.
Are you going to tell us how many errors there are before we start?
I don't know yet. I have no idea. But I'll tell you what, I'm going to take 2 or 3. I'm going to make them as hard as I can. I am. Because that's how you become a good debugger. I don't think there'll be more. There'll be somewhere around 10, I would guess. And the majority of them are going to be all the ones you've seen right now. All right. A let is not defined. Another runtime error. Alert, alert. Here's my alert. BMI status equals, something's goofed up there. See that? Logic error. And it's not adding. So I know something's missing there. All right? Now, that's not every error that you can possibly get, etc. But what I tried to do was just show you the types of errors you're most likely to get in a program. Now, there's other things that you can do as well. If you would, please look up on the screen here. I don't know if you've ever seen me do this or not. This area where you've got the numbers right here, this area that's gray, that's called the gutter. And notice if I click on there, of course it's not doing it. Why not? Well, what it's supposed to do is it's supposed to put a little dot there. And what that means is that's called a breakpoint. All right? And you can put breakpoints in, so I can come in here where we just were. Oh, I closed it, so I'll have to open it again. So I can come through here like this, okay, and I can hit the F12 key, all right, and I can come through here and I can say, where is it? I think it's under sources. I can come through here and choose what I want to look at. Notice Control P says I can open a file and put it in here. Then in that file, I can click on the left-hand side and it'll put one of those dots in there. What happens with a breakpoint is the program breaks or stops at wherever it finds a breakpoint. All right, they do show you an example of it in here. Okay, so there's been a breakpoint that's been set on line 20. When it hits that line, it stops. That line has not yet run. That's the line of code you're on. But you can take your mouse then and put it over different variables and find their current value. That's another way that you can debug. Not only that, you can, if you want, you can use these things here. Step into, step over, step out, and resume. All right? When you use the step into, sometimes that's the best way. You're writing a program. It's like, I'm 100% sure this program is correct. However, I'm getting wrong output. So you can hit F11. That will run through your code a line at a time. So you can stop it at any time and look to see where, what the value of something is, what's happening with it, etc. How else can you do this? They talk about a trace. Guess what? I already showed you a couple of these. All right. If you remember in the example that we went through before, and I think it was the BMI one, but with this alert right here, the way this is set up right now with that alert, if you look on the screen, every time I run this program, it's gonna print that on the screen. Would you agree with that? Maybe after a while, I'd like it to print, but I don't want it to print on my screen. So what I can do is I can say, instead of saying alert, say console.log, like that. All right, then come in and run the program again. All right, in fact, let's hit F12 right away. It's not running yet, so that's not going to work. All right. So we run this. There, oh, not that one. We launch that. I hit F12. Boom. I come over to console. Now I run the program. 72, 72. See where console gives you the output? Right in a console log window. So if you don't want your screen to be constantly where you're putting in alerts and whatever, you can use console.log, all right? And you can have it show right in the window, the developer tools window, if you want to do that. You don't have to do that, but it's just another thing that you can do. And then they're showing an example of it down here. Am I right in assuming we all know that if you right mouse click and you choose view page source, that you can see the code? That's what they say in there. So we've already gone through that. Then the chapter ends with validating HTML. All right. We haven't even been doing that because the HTML we've been writing so far has been very minor. All right. So that's it for that chapter. Any questions on anything that is in Chapter 5? Right?